So far in our study of CVP analysis, we've been focusing on one product at a time, be it a light bulb or a desk lamp or fairy lights. Companies sell a magnitude of different products in their normal product line. There's not a lot of companies that are one product companies. Most companies sell hundreds of different products. They have what they call a sales mix, which is the proportion of various products that constitute a company's overall sales. Usually companies don't sell the products evenly. Like, it's not like they sell 8 products and each product is 1/8 of their overall sales. Some products sell more than others, so this is a weighted proportion, if you will. If you can do this for 2 products, you can do this for 200 products, but it just gets much larger. So I'm only going to ask that you know how to do this for 2 different products in a mix, and that's exactly what Gaslight has in our example here. At one of their production facilities, Gaslight manufactures 2 products. They manufacture ceiling fixtures and they manufacture sun lamps. These ceiling fixtures are going to sell for $120 a pop, and they have a unit variable manufacturing cost of $70. The sun lamps sell for $90 a piece, and they have a unit variable manufacturing cost of $50. Gaslight expects that its overall mix is going to be the sale of 1,600 sun lamps and 800 ceiling fixtures during this period. They're being manufactured at the same facility, and that facility has a total of $56,000 in fixed costs. So these 2 products have to, if you will, come together to cover those $56,000 in fixed costs, which the production process for each shares. So what is the expected operating income from this bundle of products that are going to be manufactured at this facility? Well, we can do this in a chart like we've seen before. And our first step is to figure out our unit amounts. What is our unit amount for sales revenue? Well, we have 2 different products. The unit amount for sales revenue for our ceiling fixtures is $120, and the unit amount for our sun lamps in terms of sales is $90. We're going to sell them for $90 a piece. What is the variable cost to produce each of these 2 different types of units? The variable manufacturing cost for ceiling fixtures is $70, while the variable manufacturing cost per unit for sun lamps is $50. So what is each product's respective contribution margin? Well, if we're selling ceiling fixtures for $120 and they cost us $70 in variable cost to produce, each ceiling fixture that we sell is going to contribute $50 towards covering our fixed cost. And for the sun lamps, if they sell for $90 and have a variable cost of $50, each one of those is going to contribute $40 towards covering this facility's fixed cost. And once again, this facility's fixed cost in total are $56,000, which both of these products have to help cover. What is the expected sales volume for each of our different models? Well, we're expecting to sell 800 ceiling fixtures and 1,600 sun lamps. And I know they're reversed in the text. I apologize. So in total, that is 2,400 units that we are going to sell. Well, to figure out what amount of operating income we're going to have, let's figure out what amount each product we have is going to contribute towards our margin, towards covering that $56,000 in fixed costs. And we're going to do so by taking the expected sales volume for each model and multiplying it by the unit amount. If we sell 800 ceiling fixtures at $120 a piece, 800 times 120 means that the sale of ceiling fixtures during the period is going to produce sales revenue of $96,000. Those ceiling fixtures have a $70 variable cost, so 800 ceiling fixtures costing $70 in variable manufacturing costs a piece is going to cost us $56,000 in total. And if we generate $96,000 of sales revenue against $56,000 of variable costs, the contribution margin from that for that product, the ceiling fixtures, is $40,000. What about sun lamps? We're proposing we're going to sell 1,600 of those, and we're going to sell each one of them at $90 a piece. Well, 1,600 times 90 is $144,000. So if we do indeed move that many sun lamps at our target sales price, we are going to generate $144,000 in sales revenue. Each one of those sun lamps is going to cost us $50 in variable manufacturing cost to produce. So in total, the 1,600 sun lamps is going to cost $80,000. And if we make $144,000 in sales revenue against our $80,000 in variable manufacturing costs for the sun lamps, that product is going to provide us with a margin of $64,000. So in total, we're going to generate $240,000 of sales revenue. $96,000 from the fixtures and $144,000 from the sun lamps. In total, we're going to incur $136,000 of variable costs, $56,000 to produce those ceiling fixtures, $80,000 to produce the sun lamps. And those two products in total are going to provide an overall margin of $104,000. This is a good point where you can check, because if we have $40,000 from ceiling fixtures and $64,000 from sun lamps, you add those two together, you get $104,000. If we're going to do $240,000 in total sales revenue, and it's going to cost us $136,000 in variable cost to produce those units, $240,000 minus $136,000 is $104,000. So this number over here for your total contribution margin should be equal to your total sales minus your total variable cost, but it should also be equal to the contribution margin for each of the different product lines in your mix. And since we have $104,000 in total contribution margin, which we can pay towards covering our fixed costs, but we only have $56,000 in fixed costs, that means that if we do indeed sell 800 ceiling fixtures at that proposed selling price, and they cost what we think they're going to cost in terms of variable costs to produce, and we sell 1,600 sun lamps at that proposed selling price, and they cost what we think they're going to cost in variable costs to produce, that means that after we account for our variable costs and our fixed costs, we should generate operating income at this facility of $48,000. It's a quite easy process to come up with the break-even point for your mix. It's the number of each one of the units in the mix that you must sell to break even. In essence, what amount of these units must be sold at the given ratio that we expect to sell them at in order to have operating income of 0. And to do this, you need to find out what your bundle is. And it's the total number of units in the ratio with that ratio expressed in lowest terms. So for example, if we have a company and they expect to sell 300 units of product A and 200 units of product B, 300 to 200 is a ratio expressed in lowest terms is 3 to 2. We're going to sell 3 units of product A for every 2 units of product B that we sell. And our bundle size is 5. The best way to think about bundle is out of every X amount of products, we expect this amount to be product A, this amount to be product B. In our case, out of every 5 units that we sell, we expect 3 of them to be product A and the other 2 to be product B. And now that we know our bundle size in lowest terms, and we know what the ratio is of the products within our mix, how they make up that bundle, we can figure out what our contribution margin is expected to be for that bundle. So product A has a $2 unit contribution margin, while product B only has a $1 unit contribution margin. To figure out your contribution margin per bundle, you take how many units of that particular product are in the bundle and you multiply it by its unit contribution margin. Since 3 out of every 5 units that we sell are expected to be product A, we take the 3 units we expect to sell times product A's $2 unit contribution margin. For every 5 units we sell, 3 of them will be product A, providing us with a total margin of $6. The other 2 units in our bundle will be product B. And product B only has a $1 unit contribution margin. So those 2 units of product B that we move at $1 per unit contribution margin means that product B is going to provide us with a $2 contribution margin. So out of every 5 units that we sell, the overall contribution margin, given the makeup of our bundle, is expected to be $8. Let's do this for a larger set of numbers. We have Gaslight. They're going to manufacture 2 items at one facility, touch lights and night lights. And during the period, they expect that they're going to sell 6,000 touch lights and 4,000 night lights. We could go through them. We could do these calculations with 6,000 and 4,000. The problem with that is you're going to get huge numbers that you have to work with. It's much easier on you mathematically to reduce this down to lowest terms to start with. So if we're going to move 6,000 touch lights and 4,000 night lights, let's break that down instead of a ratio of 6,000 to 4,000 to something a little smaller and more manageable to work with. The best way to do this is find the biggest number that both of those numbers are divisible by. The biggest number that can go into both 6,000 and 4,000 is 2,000, and 6,000 divided by 2,000 is 3, and 4,000 divided by 2,000 is 2. So instead of saying we're selling 6,000 touch lights for every 4,000 night lights we're selling, we broke it down to lowest terms when we're saying we're selling 3 touch lights for every 2 night lights, and therefore our bundle size is 5. Again, out of every 5 units that we sell, 3 will be touch lights and 2 will be night lights. And now that we have that information, we can figure out what our contribution margin per bundle is. For the touch lights, we're going to sell them for $20 a pop. Each one of them is going to cost us $12 in variable manufacturing costs to produce. That means the touch lights have an $8 unit contribution margin. For night lights, we're selling them for $10 a piece. And each one of those has a unit variable cost of $7. Therefore, each night light that we sell will have a $3 unit contribution margin. And now, for our bundle, we take the number of that type of model that we have in our bundle and multiply it by that product's unit contribution margin. 3 out of every 5 units sold is expected to be touch lights, and touch lights have an $8 contribution margin, which means those 3 touch lights that we sell at a margin of $8 a piece will generate a total of $24 of margin. 2 out of every 5 units that we sell are expected to be night lights, and night lights have a $3 unit contribution margin. So if we sell 2 night lights in each bundle at a margin of $3 a piece, that's a total of $6. So for every 5 units that we sell, we're going to sell 3 touch lights and 2 night lights, but the total margin that we're going to generate from the bundle, if you will, at that proposed sales mix is $30. We have a bundle contribution margin of $30. And you can go and figure out what your break even is in bundles by taking the fixed costs that are being incurred amongst all of the different products in your mix and dividing it by your contribution margin per bundle. So for Gaslight, their total fixed costs are $45,000. We just determined that our contribution margin per bundle is $30. So $45,000 divided by 30 is $1,500. We're going to have to sell 1,500 bundles to break even. Well, how many of each product are we going to have to sell? Like, yeah, if we sell 1,500 bundles, how many touch lights and how many night lights are we going to sell? Well, we know how much of each bundle is made up of that particular product. In each bundle of 5, if you will, there's going to be 3 touch lights and 2 night lights. So if we sell 1,500 bundles and there's 3 touch lights in each one, that's 4,500 touch lights we're going to move. If we sell 1,500 bundles and there's 2 night lights in each one, that's 3,000 night lights we're going to move. And in total, that would be 7,500 different units. Well, now that we know how many total units are going to be sold of each model, we can multiply that by each one of those particular models' unit contribution margin. We're proposing to move 45,000 touch lights, and we know that each touch light has a unit contribution margin of $8, the $20 sales price less the $12 variable cost. Well, 4,500 times 8 is 36,000. So if we do sell 4,500 touch lights at those points, we're going to generate a total margin of 36 grand from the sale of that product. We're also saying that we're proposing to sell 3,000 night lights, and we know that each night light has a $3 unit contribution margin, the $10 sales price for each unit, less each unit's variable cost of $7. And if we sell 3,000 night lights, with each one having a $3 unit contribution margin, that's $9,000 in total margin we're going to generate from the sale of night lights. And if we generate $36,000 in margin from the sale of touch lights and $9,000 in total margin from the sale of night lights, that totals up to $45,000 in overall contribution margin across all of the products in our mix, which is exactly enough to cover our $45,000 in fixed costs. So we just proved here by doing a little bit of math that indeed this is the number of bundles, this is the number of units in our overall mix we're going to have to sell to break even.